We talked about how execution contexts are created and how that is related to variable and function hoisting. That was the first step of the creation phase. So let's now talk about the second step, the creation of the scoping chain. So what does scoping even mean? Scoping basically answers the question, where can we access a certain variable or function? In JavaScript, each function creates a scope, which is a space or an environment in which the variables that it defines are accessible. In many other programming languages, a scope is also created by if blocks, for blocks, or while blocks, but not in JavaScript. So here in JavaScript, the only way that we have to create a new scope is to write a new function. And this is something very important in JavaScript. Also, in JavaScript we have lexical scoping. And lexical just means where something is written in the code. So it's about the position of something within our code. Lexical scoping means that a function that is lexically within another function, which means that it's written inside of another function, gets access to the scope of the outer function, also called the parent function. And with that, it also gets access to the variables and functions that the parent function defines. But let's look at an example to get a better idea of this. So here we have some more demo code. In blue, we have the global scope, which is the scope that is accessible from everywhere, from all functions. Like the global execution context, you can think of the global scope as the default scope. So in this scope, we have access to the variable a and also to the first function. In orange, we have the scope of the first function, which defines the variable b and the second function. And this is a local scope, not a global scope. And do you remember what I said about lexical scoping in the last slide? Thanks to lexical scope, this scope has also access to its parent scope and all the variables and functions that it defines. And in this case, that's the global scope. And finally in green, the scope of the second function. In there we have a console.log statement which attempts to print the values of variables a, b, and c. Now, these variables are not defined in that function, only c. But as we already know, a scope has access to the scope of the function in which it sits lexically. So when running this code, the JavaScript engine will not find variable b in the current scope, right? So it just goes up and looks in the scope of its parent function and says, oh, here is b, so let's use that. And the same happens for variable a. It does not find it in the current scope, and also not in the parent scope, so it goes even more up, all the way to the global scope. And this is exactly called the scope chain. Only if the JavaScript engine does not find the variable anywhere, it throws an error and stops execution. Now, it's very important to note that this does not work backwards. For example, the global scope will never ever have access to the variables b or c, unless we return the values from the functions. So locally scoped variables are not visible to their parent scopes. And this is why I put that red arrow pointing upwards, because that's the only direction the scope chain works. Now, how does this actually work behind the scenes? Remember the execution context object that we have been talking about before? In the creation phase, each execution context object will get the exact scope chain, which is basically all the variable objects that an execution context has access to. Because remember, the variable object is what stores all the defined variables and functions. So in this example, in the second scope, we have access to the variable object of the second functions, of the first function, and the global variable object. So what do you think will happen with this code in practice? Let's go back to our text editor and find out. So I have this code already here in my starter code, which is the one that you will have available for download. So here's the exact same code that we had in the slide before. So how exactly do you think this is going to work? I'll give you a minute to think about it. Alright, so let's see the solution. Great, so the console log actually printed variable A, B, and C. So hey, hi, and hello, right? Hey, hi, and hello. So why does this work? So this works because, of course, the scoping chain. And in this case, thanks to the scoping chain, the second function has access to the variables of the first function and of the global scope. And that's because the second function is written inside of the first, which in turn is written inside of the global scope. And that's why we call it lexical scoping. So another extremely important concept and very much used in practice as well. Alright, so we have seen that the concepts of execution context, scope, and scope chain are very related. Now before moving on, I just want to make sure that you really understand how these are related and where the differences are. So we saw that the scope chain for each execution context is stored in the execution context object. But I just wanted to make very clear that the execution stack is different from the scope chain. So here we see another simple code example. And we already know how the execution stack works, right? So the first function gets called, which then calls the second function, which in turn calls the third function. And for each of these calls, a new execution context is put on top of the execution stack. Now, for the scope chain, things are a bit different. We see that the global scope contains the A variable, as well as the first and third functions. Then the scope of the first function contains the second function. And this is how I like to represent it. Now let's remember that the execution stack is the order in which functions are called, but the scope chain is the order in which functions are written in the code, where they are lexically in our code. So the order in which functions are called does not determine the scope of the variables within these functions. What determines the scope of variables is where the functions are written. Since the third function is not in the scope of the second function, of course it cannot access variables B and C defined in the second and first functions. It can only access the global variable A, because the function is written in a global scope. So, it's the execution contexts that store the scope chain of each function in the variable object, but they do not have an effect on the scope chain itself. This is important to understand. So what do you think will happen in this case? Let's go find out. Let's first analyze the code that we have here. So we have in a global scope the var a, which is defined as hello. We have the first function here, and we have the third function, all in the global scope, or in the global execution context. And then inside of the first function, we have the b variable, we have the second function call, and the function declaration. And we already know that because of hoisting, we can call the function before it's written here, right? Okay, and then in the third function, we just define variable d and attempt to console log variable c. Alright, so I'll give you a minute to think about what's going to happen once I hit the refresh button here in order to run this script. Okay, so I'm going to do it. I'm going to push the button. Alright, and so we have an error which tells us that C is not defined. So two things here. The first thing is, why can the second function even call the third function? So this bug here came from line 73, right? which means that someone or somewhere this function was called, which of course was here. So the third function was called from the second function. And this once again is possible because of scoping. The second function has access to the third function because of the scope chain, right? So the second function has access to the global scope out here, in which the third function also sits lexically. And so the second function has the ability to call the third function because of the scope chain. And there's nothing new here, right? And now the second thing is, why do we actually get this error saying that C is not defined, even though it was the second function who called the third function? So the second function is the function that defined the C variable and then called the third function, but still the third function cannot access variable C, which it is trying to print here, which as we see resulted in this error. So by now I'm sure that it's obvious to you that the third function cannot access variable C because the execution stack is different from the scope chain. And so to answer the question, who can access the C variable, the order in which the functions were called does not matter. All that matters is that the third function is in a different scope than the second function, and so it cannot access variable C. So which variables could the third function actually access? So try to figure that out by yourself. So did you get it? Okay, so it's variable A and D. So let's just test that. So I'm going to console log this one here and then do console.log A plus D. And if I run this now, then I have hello John. And hello is A and John is D. So these are the only variables that we have access to because they are in the scope chain for the third function. Great. This is really cool, right? You are already familiar with a lot of super important and advanced JavaScript concepts here and a lot of important theory. And I can absolutely guarantee you that you already know a lot more than a lot of JavaScript beginners. So this is amazing, right? There's only one thing that we have left in this section, and that is the this keyword. So let's go right to the next lecture where we are going to talk about that. See you there.